How's it going so far? Good, great. Did you like the keynote? Because it's very remotely related to what we're going to talk about, because there will be stuff about precondition, post-condition contracts, but in a much more practical way, I would say. So we are talking about compatibility between libraries. So, well, just to get you started, the question we're here to answer is that when we are changing the code in our libraries, what will be the impacts? Like, can we know in advance? Can we prevent some bad things from happening? That's the kind of thing we're going to answer. So we will talk about how you change impacts the API and the ABI of your library. If you're not familiar with the term, that's OK. We are going to explain them. It's about categorizing changes, because giving names to things give you power over them. So we're trying to name them so you get powerful over them. Once we have them, we'll try to find ways to mitigate the impacts if we can. And in a general way, we'll talk about how do we handle change through versioning. So a few words about myself. My name is Mathieu. I'm a C++ developer at Murex, and I co-host the user group in Paris. So if you ever find yourself at some point in Paris, you've seen all the monuments, you're bored with them, well, you can come and chat with us about C++. We will be very happy to have you. And you can reach me at a lot of things that, if you look closely, no similar handle anyway. That's the thing. All right, anyway, so how many of you are library developers? That could be open source or just a library that is used in a bigger program in your company. OK, great, you're my audience. So when you start or when you come working on a library, there are a few things you can ask yourself, a lot of things actually you can ask yourself when you have to maintain that library in the long run regarding to versioning. And so if you want to do it, there are lots of questions you can ask, and let's try to focus on I think the one who are pertinent to the issue at hand. The first question you could have to ask yourself is that, will all the users of the library reside in the same repository, in the same Git or perforce, whatever you use, shell folder, I don't know. I hope nobody does that anymore. Anyway. Yeah, that's the thing. Because if they all do, well, you're safe. Versioning is not mandatory. You can go out now. No, I'm just kidding. You're still going to need a bit of it. But technically speaking, hopefully, if you change something, one easy way to figure out if you broke something is just to try to compile it and run the test. And if your test coverage is enough, you should be OK. But I guess it's better to anticipate that to have to fix afterwards. So it won't hurt to know a bit about this and to think about versioning, even if you do not actually release version of your stuff, because everything is in the same code line. Another question you ask yourself, will you ever break backward compatibility? Like, ever. And it's hard to say we will never do this or that. It's difficult absolute, especially since you can deprecate something. Maybe because it's been 10 years, and then 10 years later you can remove it, and technically speaking you're still breaking binary compatibility or source compatibility because you remove something, so the feature isn't there anymore. There's no such thing as backward compatibility if you remove stuff, and usually as developers we want to remove old stuff because language evolve, paradigm change, but maybe you just get a better idea of what you were supposed to offer. So it's hard to not do that at all. So if even rarely you will have to do it, you're going to need a way to say, OK, this is a really breaking change, and users will have to take action to get along with it. And that's an important notion. Another question, do you want your users to be able to hot swap the library you publish in production? That's a very big question that depends on a lot of things, like how do you link, what kind of library you're providing. But And maybe you don't want to care about binary compatibility at all, but I know there are some cases when this is very valuable. Let's say you're the maintainer of a very low-level system library. Imagine like the libc, the libc++, or OpenSSL, something that just everybody in the world uses or almost. In this case, you may want that. You may want to be able to tell people, okay, this is a binary upgrade, just swap the binary and it will still work. You can get a critical security fix through without telling one, well, please recompile everything that depends on me. So that's just mostly all your operating system. There are times where that's valuable. Of course, if you are doing a header-only library, that's not an option. So, well, you're already telling your users, well, sorry about that. Just recompile everything you depend on. Sorry if it was very low level. So yes, of course, if the answer is yes, you will have to monitor ABI changes. So anyway, what's the thing is, it's important to be careful when you change something. Even if you have access to all your clients, even if you can patch all the clients of your library because they're in the same code line or because you offer a patch at the same time, it's important to think about it because it has lots of ramification which we will explain in a few minutes. Of course, if you want binary compatibility, you also have to concern yourself with ABI. It's another realm altogether. And most importantly, you will have to inform your users that something has been broken, that something has changed. Because I like to think that versioning is basically communication. It's like you, as a developer, communicate with the users through versioning. You tell them, this is the changes we made. This is how you tell them you changed something. A few words about reasonable use for this talk, because as we've seen in the industry, some people may have what I would call unreasonable expectation from your code. And this is a collection of things I've heard in other talks. I've heard people requiring that line numbers do not change in your API. I don't know, but they use like underscore line or something, and if the line where your declaration is changes, something will break. I will not guarantee that, and this is not a talk. Symbol addresses, this is a big topic right now, because C++20, if you have followed, will not guarantee that you can take the address of anything in the standard library anymore, less a few symbols that have been specified. The reason behind that is that you cannot do overload. You can add overloads to your API if somebody was able to take the symbol address, because when you put a name somewhere with the ampersand operator, if there are more than one option, you get a compiler. So that's why most of the time now we tend to say no, please do not try to get addresses of our functions. Just call them through a lambda, whatever. So we will not talk about that, but it's important to have it in mind. The real type of auto types. That may be strange, but some people really dislike auto and they want the actual concrete type. You can deduce it, it's inference. You can just, okay, look up your IDE, say, okay, the real type is that, that's what I will copy. Again, that's not something we were going to talk about. I don't believe that if there is an auto in an API, somebody should store it everywhere else than in an auto, because that's the point. This is opaque, this can change, just use auto. And the layout of private members. Well, these are private members, you'd say. We should not care about that. But, well, again, if you go into the serialization world, some people may say, well, yeah, we expect your struct to not change or reverse the order of members or something like that. This is not the talk. There are some ABI concerns in the order of members, which are actual concerns, and we will talk about them. But basically, if you expect people that they will never change the layout of private members, that's not something we should concern about. So yeah, we will really not talk about this. Okay, so first, API. Does everybody knows what's an API? Yeah, that's the most common of the two I'm talking about. So I will just well, let's say my interpretation of what an API is. Basically, it's a contract between the maintainer of a library and its users. So it's basically divided in two parts. There is the precondition, which is, okay, as a maintainer, I ask you to respect the following rules. And if you do, I will follow the post condition and give you whatever I agree to do. It's a two-part contract. If the first part is not guaranteed, is not offered, then the second part is void. So that's what we call undefined behavior and all kind of things like that. It's like, you did not respect the precondition, I can do whatever I want, I'm not entitled to follow whatever I promised, because it's a two-way promise. Let's take an example. I'm sure you're all familiar with CPP reference. It's a great wiki it's actually a wiki and not an extraction of the standard. But yeah, it's a great wiki when you can find all the reference you want about this in the library. So for example, in std swap, if you look at its contract, the first thing you will see is the name, obviously, like a name of powerful, like how can I invoke this thing? It's stud swap. Okay. Then there is the place, like if I want to call this, if I want to reference this API, where can I find it? So this is the header you have to include. Maybe in the future the modules we will have to import. This is where to find it. And this is also part of an API. If you change the, we'll talk about this later, but if you change the location of a symbol from one header to another, you may break stuff for your clients. Then there are the signatures, which tells you a bit about the precondition and the postconditions in a very general way. For example, it's a function in this case that takes void, that takes two arguments of type t and returns void. We get some extra requirements here in form of precondition, which are that t, for example, in the first case must be move assignable and move constructible. If one of those two prerequisites is not met, there's no guarantee that swap will work. You may get compiler error, you may get, your cat can become pregnant or whatever, like people say in the UB talks. And finally, if we do everything well, what do I get from that contract? What's the maintainer promise to fulfill? And it promises that it will swap values A and B. That's quite tough for a simple swap, but that's basically all APIs work. In C++ term, I like to categorize those into two kinds of contracts. They are what I call internal contracts and external contracts. Why the distinction? Internal is what your compiler can check. Names, signature, location of declaration. This is things your compiler can check. This is things that if you change them, you get a compile error. This is the best kind of API change, because that's the one that's just going to raise a compiler error. And then on the other side, we got the other side, which is things we agree on, but are not part of the language, that are not part of the type system, and that if you're lucky, you will get a compile error, but in most cases you won't, because it's not seen by the compiler. It's a verbal agreement. Nothing will enforce that in the code. It's just like gentleman agreement, and it's much more dangerous. So like I said, not all parts of an API you publish or declare are seen by the compiler. It will try to enforce as much as it can, but it can't see everything because it's not part of the language. So for the rest, you have to rely on documentation, on comments, on a lot of things. And of course, that's the dangerous part, because that's the part that may slip through the cracks if there is a change that goes unnoticed. I have a few examples afterwards. Yeah, we said something about categorizing changes. So basically, there are three ways you can change your API, or maybe, no, there are three kinds of change you can make in your code that have impacts or may not have impacts on the API. There is the breaking change. Like, if I change something in my code that breaks the API, the clients will have to change their code. Otherwise, it won't work. It just won't. There's the non-breaking change, which is nobody has to change it. But if he wants to use the new features, he will have obviously to write new code, and then he would not be able to go back. Most of the time, we don't. When you use a library and you use version 2, you don't go back to version 1 or whatever. You try to stay up. But there are cases where you get something in in the middle of the development process that say, oh, well, we hit a roadblock, we have to go back to another version. Maybe there is a critical bug that's not fixed yet, and you just can't live with it, so you have to go back. That's not the most case, but it's something to keep in mind. Sometimes you can make changes that are okay, but as long as people use the new feature, they can't go back anymore. It's a one-way street. And there are finally the best kind of change you can make is the one that have no impact at all. So people can go back, they can go forward, it has no impacts whatsoever. So let's start with the easiest one, the preferred one, I would guess. It's how in C++ do you get a change that has no impact? Well, when we go back to contract is that since an API is a contract, the idea is that you did not change anything in any contract. You did not add a contract, you did not remove a contract, you did not change the wording of a contract. It's exactly the same one. Basically, you change the implementation and you still fulfill the exact same promises. For example, you could have done performance tuning, you could have done refactoring, but behind the scene you don't process things the same way, but the observable behavior through the API is exactly the same. Bug fixes technically are also in that category, because usually a bug fix is where your promise and your implementation differs. Like you promise to do something and you do something else. Well, technically a bug fix is not changing because you're actually now fulfilling the promise you should have done in the first place. Some people may argue that if a bug stays in the code line too long, it becomes some part of the promise. I could talk about it for hours. I will not, because this is not the talk. But my quick opinion on that is that the only thing you should rely on an API is the contract and nothing else. If the contract is not fulfilled, please report a bug. Do not try to observe what happens and say, okay, well, if I pass a negative number, even if it says it should not, I got what I want. No, don't do that. Okay, so in C++ terms, what are the practical impacts? It means you did not change a name, you did not rename anything, you did not rename a type, you did not rename a function, you did not rename a namespace, obviously. You did not change the signature at all, like you didn't change types, you didn't swap types, add cons, whatever. You didn't change anything in it to any signature at all. All defined behavior is the same, and that includes specific guarantees. Like for example, if you guaranteed that complexity was going to be ON, don't say there's no impact because now it's n square. The compiler won't notice, but somebody will complain. Same thing about iterator validity. It's dangling pointers are a very dangerous thing in C++. There are ways to avoid them. We have keynotes about that. It's a very interesting topic. Basically, it cannot today be enforced by the compiler, or very hardly. So you gave guarantees about iterators. If you change them, you change the API. If before that pushing an element in your collection was not invalidating all iterators, and now it does because you changed the underlying storage, this is not a non-breaking change. There is impact. So what about a change that's non-breaking? It's basically adding new stuff. It's like, okay, there is new cool stuff you can use, but if you don't want to, that's fine. Everything else still works exactly the same way. For example, you add a new function. It's fine. You add a new overload. Actually, if you go to the guarantee that nobody should use addresses of your stuff, because if not, as I said before, you can get into trouble. But yeah, adding a new overload is fine. Adding a new type is fine. Adding a new namespace is fine. It's just new stuff. Shouldn't have any impact. You can technically relax an existing contract. For example, your function operates on a domain of values. If you now accept a more larger domain of values with a new defined behavior, you just define undefined behavior. That's not going back. That's not a regression. For example, you had a function that only worked if you gave positive integers. It was undefined if you gave unsigned values, if you gave negative values. And you say after a new version, well, now we handle negative values. We always return 0, or maybe we take the absolute or whatever. You did not break anything because people were not supposed to use undefined behavior before. You just defined it now. They should not complain. They have no right to complain. if you change that. So for example, you can add a new member into a struct. Technically, you change the struct, but everything else is still in the same place, so it's fine. You can add new default argument to a function with the caveat that if somebody does not use that new default argument, it still works the same way. For example, if your algorithm worked in sequential way in the past and you add a new Boolean to say that if it's true, it's going to do a parallel computation, but by default, it will still do the old way. That's fine. You did not break anything again. Observable behavior is the same regarding to the previous contract. Something a bit more complex, you can narrow post conditions. That may be a bit difficult to understand. The idea is that if you give some strict guarantee and now you give stricter guarantees, that's not a breaking change. For example, if you said, I will return a number between 1 and 10, and now you return a number between 1 and 5. Well, 1 and 5 is between 1 and 10, so technically speaking, you did not break anything. Some code will never branch, but that's still fine. The code is still OK, and you did not break anything. If you now guarantees, it's the same. If in the past, for example, you always invalidated iterators, and now you don't, it's fine, because it's just a plus, right? People will have maybe unoptimal code now, but they still have working code. So what's a breaking change? Well, basically, that's everything else. For example, if you change the signature, if you change the return type, if you change the order of the arguments, if you change the type of the arguments, that's a breaking change, right? Something will cause an issue to the compiler because the arguments are not the same. It's not what it expected to be. Renaming, obviously, if you rename something, the compiler won't find it. And finally, if you move the declaration to another header file. That one is not one we think about a lot, but I've seen it happen, and it could be dangerous. For example, if you look back at std swap, they actually broke the API because it moved from utility to algorithm or the other way around. I can't remember. So if your code was correct, if it just included the first header and then called the code, maybe now it won't work anymore. That's a breaking change. If you try to narrow a contract, for example, if in the past you say, OK, we wanted any number, we could operate on any number, and now you only operate on positive numbers, well, half the arguments you could have in the past are now undefined behavior. That's a breaking change. People will probably want to know about this and change their code. If you relax post-condition, it's exactly the same thing. If you said, OK, I will return something that's only positive, and now you can return any number, people will get surprised because their code is not built to handle that. You said, I do not throw exception, and now you do. Same thing. People did not expect the code to be throw exception, so guarantees have changed, and and behavior will have issues. And relaxing guarantees is the same. If now you invalidate iterators every time, and in the past you said you don't, trouble will arise. That's evil. When I say that's evil, the real evil part is that you change only that. Let me explain. If you change a name, if you rename, if you change the order of parameters, if you change the return type, what happens? Compile error, right? OK, that's painful. People will complain, but they will just open the documentation and say, oh, all right, the order of the arguments has changed. There is a notice in the changelog. That's fine. OK, I know what I have to do. It's not good, but, well, breaking changes sometimes have to be made. That's OK. The problem is if you change only something that is not seen by the compiler. Because as much as we would like to, people do not read your changelog when they upgrade. The usual behavior I observe is that they run the compiler, they maybe run the test, and if it's green, it's good. And something may slip through the cracks. And you will get very angry people on the phone if you break that and they didn't notice. Even if they could have, because they could have run the changelog, but still don't do that. Let's see a quick and a very, very caricatural example. OK, so I had a function in the past called foo, which was supposed to take a vector by reference and sort it. All right? My API guaranteed that I was doing that in nlog n, because I was calling std sort behind the scenes. Okay, I make a breaking change. I say, well, now it's still doing the same thing, but the complexity is then factorial. Okay, let's say I change the version. I say, no, now it's version 2. I have a change log about that. Say, now sort is much, much more slower. And I ship that in production. People may not read your change log. And now you use bogus sort. Everybody know bogus sort? Okay, so the idea of bogus sort is that you take your pile of values, you shuffle it around at random, and you check, is it in the right order? And if it's not, you try again. At some point, you may succeed. This is actually optimized bogus sort because it tries to check if it's already sorted. It has much more chance of actually terminating than the original one. But yeah, anyway, the joke is that if you do something like this, just that, like, okay, I've changed a guarantee that's not seen by the type system, and I push a new version, you will get very angry people on the phone or physically maybe, I don't know. But okay, this will not happen in production, but something similar may happen. You may change like iterator guarantees or exceptions or a lot of things actually that make sense in your context. But what you will get people say, I did not get a compiler, so I assume it was fine. Does that seem familiar? Did any of you run into that? Oh yeah, I see a few people nodding, all right. Okay, so now changes in the ABI, because we may not like it, but sometimes binary compatibility is something we need. So let's try to talk about it a bit. So it's called ABI because it's application binary interface. So I like to say that code is how programmers talk to each other, when ABI is how binaries talk to each other. So it's convention from one program to call another program through a library or through different object files. It's not covered by the C++ standard. Almost entirely. I made a star because there is a very small part of the standard that actually has impact on the ABI, but most of the ABI is not defined in the standard. It's defined by your compiler vendor, your platform, your CPU, your OS, and a bunch of other stuff. We will go into that. So yeah, basically it's defined by two broad categories of things. First one is infrastructure, and the second one is actually the code. So left part is something that may change in the ABI if you change your infrastructure. You change your compiler, you change your OS, you change your CPU, you change some compile flags, you change the runtime you use. Well, that's infrastructure issue. My recommendation here is just make sure you use the same infrastructure as your clients. That's a very, very broad topic. I will not address that now because I could be on for hours again. I will just try to focus on the second one, is what change in your code can have as impact on the ABI. What change in your code will make people, I would say hungry, but at least will have some impacts on the code, on binary compatibility. It's mostly about symbol names, the representation of types, and vtable. Let's delve a bit into that. Who knows what mangling is? Okay, so a good part of the audience. So just to recap very quickly, when we moved from C++ to C, we didn't want a new linker. So we needed a way for the same old linker to work with our new symbols. We now can have like colons and const and reference and a lot of things that were not parts of the standard C ABI, which is just a string name. So what we did is that we invented an algorithm that depends on your compiler, basically, which translates a C++ declaration into something that the linker can actually eat, because it can only eat stuff like strings, lowercase, uppercase, underscores, and numbers, and that's all. So obviously, you need something else. So for example, if I have two functions, foo, one takes an int, the other takes a double. In C++, that's two different functions. In C, that's undefined because you can't have overload. They cannot have the same name. So what we do here is that the compiler, you will see, have an I or a D at the end to distinguish both and say that there are both different symbols. That's the basic of the ID. And so what's important in there is that if we change something here, like if we change the signature, we break the ABI, right? Because the name of the symbol in the library is not the same and the linker will not find it anymore. Here I'm talking about DLLs, shell libraries, that kind of stuff. Basically, ABI concerns is when you ship binaries that people use directly because they link it or because they require it at runtime with DL open or with dynamic linking. All right, so if there is a name somewhere that says, okay, my function, if I want to say find foo, I have to find this symbol, that's hard-coded in the binary you generate. So if you upgrade your library, the linker of your clients will still look for that, unless they recompile. That's the whole idea of the ABI, is that here is the name of the thing we use, of the symbols we export, so that you don't have to recompile. And the problem is if you change the signature, you change the name. And so you change the name of the symbol, you get link error. So for example, in this particular case, you might say that it's a fine non-breaking API change, right? Because before you only you took integer, now you took double. Well, you can translate integers into double in a safe way. That's not an narrowcast. So you may classify this as a non-breaking change. All right, now my function accepts any kind of number, real or imaginary or whatever. But no, because in ABI terms, you will get binary errors. So binary compatibility will not be granted if you change that. That's the kind of notion we're talking here. So yeah, if you change the ID of any public symbol in your code, then binaries compiled against your library cannot be will not work if you just swap your library against them in production. That will not work. People will get errors. And this is very important, like I said, if you have low-level system libraries that everybody relies on and that they upgrade from time to time for all clients, or maybe you have multiple clients with different versions of your code. They all link to the same library because you provide backward compatibility up to a certain point. That's the thing you have to think about. And the tough thing is, which symbol do I have to care about? Like, there are a lot of symbols in the library. Which one are the one you should care about, right? One easy idea is to say, well, it's easy. It's the name of everything I publish in the API. The other stuff is just private stuff. People should not reference them, so it should be fine. But there is a caveat. What if I use inline? For example, here, you put something that you would say is implementation details. Usually you put them in a separate namespace, which is called internal or details or private, or please do not use that, or I don't know what's your convention at home. But since we do more and more inline stuff, sometimes you put stuff in header files that's supposed to be implementation details. People should not use that. You have a lot of that in the standard library if you open the STL headers. You should not use the __ stuff in the STL. You should just use what's in the standard, right? That's the same idea. So there are lots of things actually in your header files that you do not consider public and that you think are not public, but actually the linker have to see them. Because, for example, if you use an inline function, it will just squeeze everything and reference directly the implementation detail. It's usually fine until you get into ABI, because, well, then you get a problem. If we go there, for example, I have a function that's called foo, that's my public API. It's void, returns void. Fine, great. I've changed it. No, I didn't change it. The API is exactly the same. I just changed implementation details. Maybe I did a refactoring or whatever. So now I'm calling an internal function which takes 1 argument before it did not have any argument. From an API perspective, it's fine. I didn't change anything. But from an ABI perspective, I changed a symbol that actually is public. Because the compiler will inline the function and directly call the symbol here, which is private. And that's where that's where I think Microsoft got it right. Because by default on Windows, if you ever worked on Windows and with DLLs, you know that you have to have this ugly macro or DL spec or whatever to tell the compiler this is a public symbol. It should be exported through my ABI. People should be able to link against it. On Unix, you don't have to do that. On Unix, every symbol by default in your library is public. People can reference them. So I guess that's one point for the Microsoft compiler there, but because at least it gives you an easy way to know which symbols are actually public symbols in your code. That's all the ones with that export macro. So anytime you see in a change list, code review, whatever, someone changing an export a line with an export macro, you know you broke the ABI, most likely, because you rename a symbol or change the signature. OK, vtable layout. I'm not going to talk as much as this, but if you use virtual, we try to use it less and less, but you may use it. It's fine. Your compiler will have to translate the notion of a virtual object into code, into binary, sorry. And to do that, it creates a small table called the vtable in which it stores usually function pointers to your actual methods. So when you have an object, it has a pointer to a table which contains all the pointers to the methods you should use when you call virtual functions. It depends on the compiler you use. And if the layout changes, obviously two binaries will have a different understanding of what's a virtual method foo, because the offset in the table will change. Usually, if you change something if you add a virtual method, if you swap the order of virtual methods in a class, you break the ABI, because the vtable layouts will not be the same from the two perspectives of your code and your client code unless they recompile. And you get surprises. I've seen them. And when I see them, a rough example, let's say you're building financial stuff, OK? You have an object, and it has two methods, buy and sell. And at some point you say, well, this makes no sense because they are not in alphabetical order, and I like my method by alphabetical order, so you swap them to the other side. And well, if you do not recompile your clients, now people we were expecting to call buy will now call sell, and the other way around, and you get very nasty surprises in production if that happens. I'm not saying it happens to me, but we got some issues that were more like new and delete, which are also usually the first two methods you define, or it can be a lot of fun. And it's very hard to determine which one will get called. The idea is that it will be the wrong one. OK, binary representation of types. You know, your compiler knows about your code, but your processor does not know anything about your types. All it knows is that it has an offset and a size. It's just everything is pointers to them. That's basic stuff. Oh, sorry about that. So when you actually input a structure in C or in C++, the compiler translates that to and tells the assembler, all right, this public member is as offset X and its size is Y. And of course, two libraries talking about the same object must agree on the representation of the type. So let me give you a quick example. Here is a struct, struct A, I call it, very original. It has four members. First one is an int, second one is a bool, third one is a char star, and the last one is a double. OK, so on my machine, and I think that's one of the key things of the ABI, on my machine, because it depends on a lot of things. On my x86 machine, that's a Windows example, but I think Unix is exactly the same one. On that matter, it could change. An int is 4 bytes. So the layout will be like this. I will have from 0 to address 4, I will be 4 bytes reserved for my int, which is M1. Then I have a bool, which is just after that, at address 4. Then I have a char star, which is a pointer on a 64-bit machine, so 8 bytes. On my machine, again, you cannot have an object that is not stored on a multiple of its size. It must start for alignment, basically. It's called alignment. It's for optimization reasons. Your CPU is much better at accessing things that are on a boundary that's a multiple of their size. So basically, all your pointers will have to start on a multiple of 8. That's why you get padding here. And that's why M2 is not directly after M3, the other way around. And then I put a double, again, 8 bytes, and it's stored right there. So that's how I see my structure. That's how my compiler sees my structure. But that's how my CPU and my binaries see my structure. That's my structure for them. That's all they care about. So all my libraries have to agree on that. Because if they don't, Same way you can call a funny function that's not what you intended, well, you can change a funny value that's not what you intended. And a lot of bugs can be traced to that. Example, let me add something here. Okay, I had a member here. It's going to go to the end. And on my machine, the observable part of the structure will still be the same except for the size. So if it's just referring to the address of each member and their size, both versions should be able to talk to each other, even if one sees it like this and the other one sees it like this. The first one will only care about the members it knows, and it will find them at the same place he wants. So you should be fine, but I do not recommend you rely on that. Exceptionally because it's really unpredictable, and like I said in my example, it's on my machine. There's a lot of rules that depends on your CPU, on your OS, and on your general compiler that defines how this thing gets translated into that thing. And so the general rule is that if you change the order of your members in a struct, the ABI breaks because the offsets of the members may change. If you add a new member, you will most likely break it. It's not a 100% guarantee. There are some tricks that date back from C that may be used to keep binary compatibility, but they are risky, and I do not want to be responsible for you putting them in production, so I won't show them here. And of course, if you change a member visibility, it may also break ABI. And that's a callback to the, remember when I said that a very small part of the standard define the ABI? That's that small part. It says that if your struct is just a struct, like a plain struct with everything with the same visibility, the rules of the ABI of the rule of C to be compatible with C, basically. If they are public and private members, then it's C++, and then you are not supposed to be guaranteed the memory mapping of the stuff, and the compiler can do lots of funny things with that. So if you change the visibility of one member from private to public, you can switch from the backward C case to the new C++ case, and the layout shifts completely, even if the order is the same, because the compiler has the right to reorder them. It doesn't have the right in C, because structures are supposed to be possibly mapped to memory I/O, whatever, like devices, something like that. In C++, if there are private and public members, the compiler has the right to rearrange them for performance reasons. So you might get surprises. OK. Yes?
What would happen if you put M5 in between M2 and M3 to take advantage of the padding in your example?
OK, so you heard it from him. You did not hear from me. That's one of the tricks that you can use when you need to add a member to a struct but don't want to break the ABI. But you did not hear from me, because 1% of the time it will save you, because you have to patch a binary into production and you cannot recompile everything. And 99%, it will kill you. But yes, technically, you can take advantage of the fact that there is padding here, and if you know perfectly the alignment rules of the platform, and it's the same alignment for all your platforms, blah, 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 you can try to put M5 between M2 and M3, and it should be in a place where the binary will not look for, because it's supposed to be unused. In theory, C programmers have been taking advantage from that from a long time, and we've also had to debug nightmarish case because of that. So again, you hear it from that guy, not from me. I'm not responsible. OK, joking aside, versioning, because we talk about changes and all that, but versioning, how do we advertise it through versioning? So I would say there are two schools of versioning. There is the one you know, and there's the other one. I'm not saying which one is better. I will let you make your own opinion on that. The most classic one is semantic versioning and everything that derives from that. It's the most natural. It's something we all use, even if our daily life, like version 1. Something. You know, even non-tech people now start talking about version 1. Something or version 2, whatever. It's basically some kind of scheme with one or more numbers that we increase when the version changes. The most common is semver, or semantic versioning, which is X, Y, Z, 3 numbers. It allows for parallel release, like you can have a major 3 branch and an older 2 branch when you still release versions, like if you have to maintain older version of your stuff, kind of things. If you have multiple clients that refuse to upgrade, for example, that's a very common case in the industry. You may maintain several versions in parallel. That's a very common thing. And Semver allows that, but there are others that don't. It's a fairly complex scheme because you have 3 numbers and incrementing each one of them has different meaning. It allows for asynchronous upgrade because you can say, okay, I published a new version, but you do not have to use it right now. You can use it tomorrow. You can use it in 10 years. We can try to maintain backward compatibility for a long time so you don't have to change your code. It can stay alive long, and you can have a lot of versions alive at the same time, possibly forever. And of course, since it cares about a lot of versioning and a lot of different versions, it also cares or enables you to think about binary compatibility. We'll get more on that. For those of you who have seen the keynote at CPPCon this year, what's his name? I'm sorry about that. Titus Winters from Google came up with something we call Live at Head, which is the way they envision versioning, which is about basically a lot of opposite thing from Semver. The idea is that you do serial release, and when I say serial, it's just like a serial number you increment. There is no complex scheme. It's just like a number that changes. You could even use Git SHA-1s. I do not recommend that because there is no order relationship between commits. So I would prefer like a timestamp or whatever, but technically it's just a number that keeps increasing. It's source-based, which means it doesn't care about binary compatibility at all. It's a strong design choice, which is I don't care about binary compatibility, just recompile everything. The only thing we care about is API, no ABI. It comes with advantages. So for example, there is no diamond conflict. I will come back to that. But the diamond conflict is where you have 2 libraries used in a project that both require a different version of the same dependency. That's the diamond pattern. And the idea goes that the bigger your project you get, the higher the chance that you get one that is unsolvable. Because you have 2 people requiring 2 major incompatible versions of the same thing. And it's a lot focused on automatic client code migrations. So let's go back first to the traditional one, just to get that out of the way. So it's a formal convention to express compatibility between versions. It was published by Tom Preston-Warner in 2011. Actual similar schemes have existed for much longer than that. And it's 3 sequences, X, Y, Z, major, minor, and patch. I guess most of you are familiar with it. The idea is that major releases are API breakage. It means that people will have to change their code. They have to expect that something will not work the same way. Minor release means new stuff that you can take or not take, but it's safe to upgrade without changing your code. And patch releases means, OK, we just fix bug, we just improve performance, whatever. There is no issue at all. You can even go back if you really need to. It says nothing about ABI because it's generic convention, and technically speaking, ABI are an issue with native language. It's not something you have with language that only works at source level. But we can fix that, right? We can add ABI to Semver. It's not hard, actually. You just say that if you break the API or the ABI, it's a major change. If you change the API in a non-breakable way or the ABI, it's a minor change. And if you did not change any of that, that's a patch. Easy. It allows you to offer some degree of binary compatibility. And again, depends on your use case. It's a pain to deal with, but sometimes it's very, very beneficial to your clients because they cannot afford to recompile everything they depend on. It allows upgrades. It even allows rollbacks in sometimes, which, well, software has no bugs, yes, but yeah, sometimes it has, and rollback is the best option. You can work around the diamond inheritance issue up until a certain degree which is as long as the major is the same in all the graph, you just take the highest version and people should get along. But if there are usually two different majors that are required, you're probably out of luck. And then it becomes the endless debate of, please, can you upgrade so that I can upgrade? No, sorry, I have other things to do. That's not my problem now. It works on my machine, blah, blah, blah. It's a problem that's actually very common in large-scale software, which is you want to use a new version of something, but the other libraries you depend on require another version, and they don't want to pay the cost for upgrade because they have other things to do. So you get stuck because they are stuck. And it becomes very painful to make things moving. And still, it's the most common scheme today, right? That's the usual one you will find on GitHub on a lot of projects. Let's talk a bit about the other one, Live@Head. It's fairly recent. It was coined by at CPPCon 2017, so in last September. The idea is that you increment a serial number. You force everybody to use the same version across a given binary. And how do you do that? Well, it's simple. You say, just recompile everything every time. Done. And finally, it puts a strong emphasis of, if you have to break something in the API, give a Clang patch. Like, if you know Clang tidy, you can script it in C++ to generate patch based off code. Basically, it explores the code of the clients, the abstract syntax tree, and it suggests patches. It's usually used to modernize your code or to find like performance or readability issues and suggest patch. You can write your own to automate changes. That's what Google does. That's how they can change a lot of things so fast in a huge code line. There's a big emphasis on that. The idea is to see the code as data, basically. Like when you do a SQL schema upgrade or something like that, the first thing you do is that you upgrade the data that exists in the database. It's the same idea. You want to upgrade your API, well, first you look at your clients and you automatically migrate them. That's the same thing, seeing code as data. By design, you cannot have diamond issues because everything is recompiled every time. And everybody has to use the same version. You push people to stay ahead because there is no versioning outside of just a number that increments. And if you have to break something, you will give an automatic patch. So they have no good reason to not upgrade because anyway they have to recompile every time because you do not go for binary compatibility. And you will patch their code for them. So there is really no reason for not everybody to upgrade every time. Of course, and I don't know if your mindset may vary if you think that's a good or a bad thing, but you don't have to support all the release. I guess clients will be sad and developers will be happy. That's usually how I get the feedback about this. OK, so how do I include my API in my versioning? Well, first of all, pick a versioning convention. Decide for Semver, decide for trying Live@Head, try something, decide a convention, pick one. Tell your clients which guarantees you offer. We talked about a few guarantees we refuse to offer in the beginning of this talk. Make that clear. Tell people, do not try to do this. It won't work, never. It's just like, it should be a prelude to every API you read. It says something like, every time I say it's an int, I mean it could be positive or negative, that kind of stuff. Any global guarantees of decision you want to take in your API, just put it there, write it. Maintain a changelog, obviously, because yeah, I told you before that people usually do not read them. That's kind of true, but that's not a reason not to do it, because that's the reference of your API. That's what people should do when they want to upgrade. They should open the changelog and say, oh, that changed. That could also be a way to advertise new stuff. Like, hey, we added that, check it out, that's cool. Document your contracts, because like I said, the type system will only cover you so far. For all the rest, you have to write it down somewhere. And you probably have some expectations about what people give you as inputs, and you have to give some guarantees at output. You have to document that somewhere. The most common is can a pointer be null? If you do not say so, people may assume that they do. So write it down somewhere. P must not be null. You can also use reference. There's another. That's a big debate, but anyway, document what you expect. That's what you should do. And finally, avoid invisible breaking changes. Like I said before, when you change the part of the contract that's not seen on the type system, it can go through a huge number of layers. It can go through compile, it may slip through test, and end up in production. How do I include ABI in versioning? Hey, easy answer. Best answer if you can, don't. Because as we've seen before, it's not as known as API. It's painful. It depends on your machine. Basically, it's more constraints. And the best way to work around constraints is to not have them in the first place. So if you don't have to bother with it, just don't. If you can force your clients to always recompile, or if they want to, don't bother. If your library is header only, well, you can't do anything but not bother because you're header only, right? You cannot have binaries by definition. But again, make it clear in your documentation. Like, we do not support ABI. Like, do not expect our version to be binary compatible with each other. Write it down. Tell people. Or, if you have to do it, I would say go for revise somewhere, because obviously live at head will not help you there. A small mention that I added recently, inline namespaces. That's something that can also help you as a tool for versioning and migrations. Since C++11, you can make names available through code. Sorry, I lost my thought there. Yes, you can put something in a specific namespace and make it visible to the parent, while still keeping name mangling as it was used in the down level. Let me show you an example here. All right, so I have a namespace called mylib, okay, and I have two namespaces, v1 and v2. One of them is inline. What it means is that everything in namespace v2 is also visible directly in mylib. So people usually will use directly mylib, a colon, whatever symbols they want. But the compiler in the ABI will translate that to v2 because it actually resides in namespace v2. It's just an alias. The idea is that if you want to provide new functions, rename functions, or change signature of functions, what you can do is that you put everything in an inline namespace that you call v1. And the day you want to change that, you remove the inline namespace from here, you put it there. What does it mean? It means that everybody who recompiles, we use the old version. And everybody who still use we have not recompiled, still links to the other one. And both are available in your binary. This is a way to offer backward compatibility when you have to change something but don't want to impact old clients that don't want to recompile. So it's usually you say to people, do not refer to the v1 directly. Okay, just don't do that. It's implementation details. It's just a way I give you to be backward compatible even if I do breaking change in the ABI. That's the way you can change, you can add, so you can modify your API without breaking ABI. That's a possibility. You can also save, no, you cannot save API with that way. You can just change ABI. For example, if there is a public, if you change the implementation of a private symbol, or if you change a contract that accepted a short and now accept an int, you would say that it's not a breaking change because, well, if it accepted a short and now an int, it will still accept a short, so it will be fine for the client. But the ABI is not the same because the signature is not the same. That's one way to make sure that all binaries compiled against your library will still work for some time until the clients decide to recompile. What about dependencies? Because we try, or at least I try, to push people to use package managers, stuff like that, and basically rely on code from others. So there's a big question is, how does it, is there an impact there? Like if I change the version of one of my dependencies, does it mean something? Actually, it does. Basically, if you upgrade for if you upgrade for a new major version of one of your public dependencies, it probably means you will change something for your clients too. For example, if you use types from Boost in your code, and then the Boost gets a major release which changes the way the type behaves, well, people using your code will probably have to adapt anyway, because you change the type of the things you return or take have changed too. It's maybe not directly visible, but people will have to take action, even if you are still using the same names. It may also have impacts on your ABI, obviously. And if you change private dependencies, that is, which means stuff that's not visible from your client that you use internally, it can break the ABI. Because, for example, you now require symbols on the machine that are not compatible with the previous one or something like that. It usually comes up when you use diamond patterns of stuff like this. Will the future help? A bit, yes. First of all, we have a discussion on contracts. I still don't know if they will make it in 20, maybe 23. But the idea is to add more stuff in the language to enforce those nasty, invisible changes I talked about. So maybe be able to put assertions in the code that will break at compile time instead of breaking at runtime if you change the API and nothing, if you change some parts in the API but not the type system. So it's a way to add more stuff defined in the API into the language. I don't think we will get things like iterator validity or complexity, but we will get some validation on precondition and postcondition mostly. And that still will help. And modules should also help you for a very important thing that I did not talk about, which is enforcing your client to use only the public parts. Because, and we all know that, everything that's seen in a header, technically speaking, it's just gentleman agreement that stops people from using it. And as John said yesterday, people will use it. You can tell them, do not use it. It's a details namespace. It's an internal namespace. Do not use that. They will still, at some point, try to do that. They may even file bugs because you change it. They shouldn't, but they will still. With modules, you should be able to say, OK, only this part can be seen by the compiler, and everything else is compile error. So sorry, you do not get access to my internal bits anymore, even if I had to put them in a header file because of implementation details. Hopefully. OK, yeah, I did not warn you at the first, but there is a test at the end, so just to make sure that you retain everything. Yeah, a friend of mine is a teacher, so he tells me that's the best way to know that your students are following. Maybe I should have told before so that you listened, but that's more fun that way. OK, so are you ready? Great. We have 10 questions. So question number 1. OK, it's always the same question. I show you a change. It's not really a diff in a unified sense. It's just before, after, all right? And you tell me, did I break the ABI? Did I break the API? Did I change it in a non-breaking way? Did I change anything? OK? So first one, did I break anything? OK, I broke something. What did I break? Yeah, I broke both. Yes, because the name mangling will say that the signature is not the same in the symbol level. And of course, you need 2 arguments to call me, so I broke both. Great. And yeah, that's not so great, because you broke a lot of stuff for a lot of people. But OK, that's fine. You got it. OK, number 2. I took an int. Now I take a long. ABI. Did I hear API too? Yeah, exactly. API changed but compatible, but I broke the ABI because the name of the symbol is not the same. Great. You're doing great so far. OK, number 3. I have a struct. It was an int and a char, and now it's a char and an int, a char star, sorry. Did I break the API?
Yeah, you broke the API and you changed the API.
OK, so at first I thought, when I wrote this talk the first time, that I only broke the ABI and changed nothing in the API, because basically it's just names, right? Which turns out to not be true anymore, because in C++11 we got aggregate initialization, and people can use curly braces, and so now the order of your public members matters for things like structs. So yay, technically you broke everything. Good job. Okay. I have two methods, foo and bar, and I prefer the new version which is alphabetically sorted. So now it's bar and foo. Exactly, yay! I didn't break anything. Good. Okay, so this one is a little tough. I'll let you think about it. I had a function which takes A and B, and it used to return the sum. Now it returns the max. What did I change? Yeah, I changed the API. Did I change the ABI? No. Did I break the API? Yes. Did I break silently the API? Yes, I did. I'm a very nasty person. What am I doing here? No, don't do that. Don't do that. People will get very angry. Okay, number 6. Exactly the same as number 4, except there is virtual now. So yeah, vtable is not the same. I broke the ABI. Okay, number 7. I should have on my machine. That should give you a hint. On this guy machine, especially. Because he looks like the guy who does nasty stuff like that. Just kidding. Okay, so what did I break? I break the API, yes, because of aggregate initialization. What a bitch. And did I break the ABI? On my machine it works. But maybe not. I would encourage you to think you did, but some people may think you didn't. So I will not guarantee that I did not break anything here. Okay. Function took an int. Now it takes an int and an optional bool. ABI, obviously new argument. What about API? Yeah, non-breaking, exactly. Well, I'm still not happy because I broke something, but this guy is never happy. Okay, number 10, 9. Oh, wow. Did I start with 0? That's maybe why I thought 10. Okay, anyway. Foo is now bar. Yeah, that's an easy one. Yeah, I broke everything. That's the name of the symbol, just not the same anymore. Easy. Okay, 10. Last one. I used to take, it used to be I and S, and now it's I and str. API, ABI too? No, exactly. That's the maybe only change when you can break the API but not touch the ABI in any way, because, well, the layout is still the same. The binary doesn't care about names. All right, I lied. It's 10.5. So I had some stuff, details namespace that was called bar, and now it's called baz. But the public function is still foo, and still calls the internal one. Yeah, I broke the ABI because I renamed a public symbol that's not part of the API. But that didn't break anything else. Okay, good job. You got everything right. With, like crowd testing. Maybe they should do that I don't know. Okay, so I heard it's good to finish from a code from somebody else. It makes you look smart. So I would say that I think you probably have heard something like this, or maybe another wording of it, which says that no system ever became successful by breaking backward compatibility, to which I will add, especially without warning or automatic migration. Remember, versioning is about communication between maintainers and users about your change. So communicate. Thank you. Now it's the time for question. I think we have, I don't know exactly how much we have. 10 minutes.
Okay, I have a question.
Yeah.
The migration script that you mentioned when you
Yeah.
Google break the API.
Yes.
Is there like anything resembling a de facto standard that
Well, basically, they invest a lot on, I think it's Clang tooling. So it's basically based on Clang. You know, in Clang there are lots of libraries, and one of them is a parser for the AST, so the abstract syntax tree, basically the front end of Clang. You can put hooks at any point you want in the parser of Clang, just at the token parse, or at the grammar parse, or at the abstract syntax tree parse, or at the intermediate representation step. You can plug it at anywhere you want. And so what they did with what ClangTidy does, basically, it stops at the abstract syntax tree part, and then it allows you to generate patches from that. So it's not about, I would have liked if you could modify the abstract syntax tree directly and get a new file. Like, you know, manipulate a C file as raw data. Unfortunately, it's too hard, or at least it's not available now. What you can do instead is that you can access the declaration, like in text form, related to some AST nodes, and from that you can generate a patch with text. That's how ClangTidy works. If you ever use ClangTidy, I recommend you to try ClangTidy to get a feeling of what it is. Basically, it's a bunch of, I don't know, hundreds of checks or so that looks on your code and tells you if something should be changed because it's a bad performance or just bad C++ form, whatever. For example, they have checks that help you migrate to C++ 11 and C++ 17, I think, by replacing your explicit iterators with auto, by trying to replace auto putters with unique, I think, and other things like that. So what they do is that they write more scripts. So for example, it's actually not that hard. I think there are talks, a colleague of mine did one, on how to tool it for example, take a declaration, find all users of that declaration and patch them. And you can go pretty advanced, actually. It's not just renaming the thing or inverting the parameters. I think one change he did on a whole code line at my company, he replaced a function that was just a function with a template function. So it means that one of the arguments was removed from the parentheses call and put as a parameter template under brackets. And it worked on the whole code line. It's quite impressive. The only thing it needs is the compilation database, compile commands.json, I think it's called, that should be generated by your build system. If you use CMake, you can get it. It's integrated. If you use Google's one, which is Bazel, you can get it too. If you got a system, a custom build system, well, first don't do that. But if you have one, I don't know. You have to check. Basically, it needs to know how the compiler will get invoked in order to be able to parse the file. That's the idea. Yeah, I would agree that it's not really trivial because you have to explore well, it's educational, certainly, because you get to know how the compiler sees your code in terms of trees, but it's also tough at the beginning to, like, for example, match a declaration, because then you discover how many hidden casts are actually in your code, stuff like that. That takes nothing once it's translated to assembly, but that the compiler has to see because, for example, you are calling a function with a ref and your actual symbol is not a ref, so it has to cast from L value to L value reference, blah, blah, blah. So yeah, it's a bit nasty. What the way you can do to help is that they have a query engine that you can call on your code, and you can try to like tell it, show me this function, and it would show you the AST definition of one call, for example. And you can use that to create matchers and all that stuff. I won't say it's easy. I won't. It's quite complicated because C++ is quite complicated, and so far we haven't a way to have it seen as data. It would be great. Some languages are actually capable of seeing themselves as data. It's like functional language do that a lot. I think it's like a Lisp, for example, can do that. A Clojure also. C++, well, I'm not even sure that reflection will help. Maybe it will help standardize a bit how the compiler sees the code, but I don't know. So far, yes, you have to script and tool Clang, and it's a C++ program you have to write that links up with Clang. Please, look, do it in release, because I've done it in debug. It takes forever. Yes, it's not trivial. But apparently that's how Google does. And that's how they have now, I think they said somewhere that half their commits, more than half their commits are bots. They're not people. They are just bots trying to run upgrades on the code. So what they do is that they publish the new API, and then they tell the bot, OK, I want to move from here to there. And then the bot starts generating patches by module. It tries, it patches one module, it runs the compilation, it runs the test, OK, it's gone, commit. And then the next one, blah, 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 blah. And in a couple hours or days, you can get all the colors patched, and you can remove the old one. Then again, they have a pretty impressive infrastructure for that. And that's another takeaway, invest in your infrastructure. I mean, CPUs cost less than developers. That's a fact. Yeah? OK, you.
What do you think about the hourglass pattern that you use to address the API?
Sorry?
The hourglass pattern, I think is brought out a few years ago, about like you have the public path interface, then in between you have the C89 interface.
Yeah, all right, yeah, basically it's relying on the CABI to expose your thing. It works. I've seen library do that. Basically, the idea is that you put a whole bunch. Oh, sorry about that. A whole bunch of templates that acts as a gateway between your code and the CABI, and on the other side, you do that too. So each side has a template that's compiled with whatever compiler you want, and in between, they just talk with simple C symbols. The drawback is it gets hard when you start wanting to pass C++ object through the ABI, like string, vectors, or even more complicated, like if you get maps, multi-maps, hash maps, I think you have to have a C equivalent and possibly a copy, because you cannot have any C++ object crossing the boundary. So it can help you. I've seen libraries do that to avoid that kind of thing. If you have to, I guess if you do a low-level system library and you want to make sure you be backward compatible, that may be an option, yes. Sure, yeah?
Are you aware of any tools to automatically classify a change as ABI breaking?
I don't think I do. I think I saw bots on the internet that check libc for, or is that libc or libc++? I can't remember, for ABI compatibility. I wonder if it's not the GNOME project that has something about that. Maybe GNOME or KDE, some GUI for Unix that I never used for a long time now. But I think they had something at some point, maybe for C, but technically the C++ ABI is quite similar because it's just symbol names and sizes, right? That's supposed to check that, but I don't know how much automated it goes. What I can say is that ABI is quite easy to spot. In code review, you change an ABI, you change a public symbol that exported, you change something in the struct, you work the ABI. That's easy. For API, it's, I would say if you have a clear documentation with contracts, it's also easy, because you just look at the contract and you see what changed. And if it's only new sections, that's fine. If you modify existing session, you probably broke something, unless it's actually something that's, I would say, wider or better. The word is not precise enough, but that would not introduce regressions. Yeah. Well, I guess you could, yes. You could try to check out your old version, build a test suite against it, then build a new one and with the DLLs or whatever, and then relink and see if it works. Yes, that could be a way. You could, for example, usually your test project is in another project. You could probably automate that to tell it to link against other version and see if all your unit tests are still running. That could be an option, yes, interesting point. Anyone else? Now's your chance. Yeah, go ahead.
One of your questions about, for
Yeah.
Just swap the int and
Yeah.
can't you cast a pointer to an object to the first object member within it? So in that case, if the break.
You can only in some cases. I think again only if it's a C struct. I think it's a guarantee that's only if it's a C compatible struct and not if you have different member visibility. Again, compatibility with C. It's a guarantee that the first member should be aligned with the same address as the struct itself. Again, when you write drivers, that's something you may have to rely upon. Yeah.
So another one was changing from int to double, just a parameter.
Yeah.
As an API sort of compatible change. What happens if someone was passing in something like an unsigned int, where that was larger than the size of the int, and that would be like platform dependent way of converting to that, and it would just wrap around to a negative number. If you change to a double, we're now passing in a large number. And there's other things, like if you had a function taking integer and someone was passing in literal zero, and now you have an overload taking a boolean. Do you require people to pass the exact type in to guarantee
Usually when you do an API, what you ask is that you or the compiler can make a cast to the right type. What you do usually is that you rely on the compiler being able to make a safe cast, which is basically an implicit one. So usually, I would say that's okay. You obviously will have ABI breakage because the size will not of the, well, first the name will change. But even if we didn't have that, and for example in C you don't have that, you get worse problem is that the code expected like an integer in 32 bits and now it got an IEE whatever representation of a double, which is not the same at all, and you will get issues. But as far as passing in negative values, well, unless you gave guarantees about wrapping up if you go beyond int max or whatever, I don't think that's going to be an issue. I think it's an issue if your code guarantees wrapping.
But if you pass in an unsigned integer,
yeah.
It's larger than the size of an int.
Well, yeah. Well, usually I think usually that should be a compile error, but I think that's a warning. It's not obligatory a compile error, but I would say yes. It's a narrow cast. Usually it's not safe. I think for backward compatibility reason we cannot change the standard to do that. But in the general sense, you probably want to avoid that in general. That's the kind of thing when you should double conversion or whatever on your compiler to make sure that there cannot be a loss of precision in the process.
Is there anything to be said on the pimple model?
Well, yeah, the pimple model is one of the ways to minimize the impact on the ABI, obviously, because you expose as little as you can. For example, it's a good way to make sure that your struct won't change. Because basically the problem is that every user of a struct has to agree on the alignment and the size of members. If all the getters and setters are in the same library, well, obviously you can change it anywhere you want, provided that the construction also happens in the same place. But you don't even have to go as far as pimple. If you just do a class or structs, a class with getters that are not inline, well, basically they have to go through your library to create it. Same thing for the construction. The only problem is the size. Because compiler has to know the size to reserve the thing if people create on the stack. And that is an ABI breakage. The only way around it is, yes, if you use pimple, because then the size is always the same, it's the size of a pointer. If not, well, you have some types that are kind of weird, that people cannot create on the stack because it would lead to ABI breakage, but they can create on the heap. That's basically what we did in C for a long time. Yeah.
That can potentially cause ABI breakage.
Yeah.
And also, what other options we can have to avoid that rather than starting a new struct?
Yeah, but well, actually there's not a lot of things you can do. For example, libstat.c++ with GCC had to defer some changes for a long time because if you remember, stat string in up to 4.9, I think, was a violation of the standard because it did copy and write. And they had no way to change that without breaking the ABI because just the name of the members won't be the same, whatever. And there was no way around it. They even have a toggle, like I still want the old ABI, please. Minus glibc, whatever, version equals 0 or something like that. I don't think there is a lot of way, especially now that we have a lot of templates and a lot of, the more templates you have, the more risk you get that behavior on struct A on one side and on the other don't yield to the same code because it will be inlined differently into different libraries. So if the representation of the data changes, no, there's not much thing you can do beside relying on CABI and somehow, so with pimple or just an opaque pointer. That's what we didn't see, basically, like just struct something and the only thing you can do is have a pointer on it. You cannot put it on the stack. That's not what we try to do with modern C++, and I think that's one of the big push for live at head. It's like, okay, binary compatibility, I don't want to care about it. But again, Google can, because they have like 1 million server or so that can recompile their whole command line in an hour or something. I don't have that, and a lot of people don't have that. And I don't think that people using things like OpenSSL would be happy if you tell them, well, please just recompile off of your Debian machine because we patch OpenSSL. Yeah. No, I don't think it does. One of the reasons is obviously the impact. Because, well, like I said, it's defined by your platform and your compiler. So they would have all to change unless one of them is the lucky one, and all the others have to change. So what we have today is, for example, that Clang on Windows can emulate Visual Studio ABI to be compatible. And usually compilers try to, well, there's no standard for ABI on any system, technically speaking. But there is a general consensus that comes from the first compiler developed on the platform. And then compilers on that platform try to emulate the behavior. For example, on Windows, like I said, Clang will behave like Visual Studio in terms of calling convention, alignment, blah, blah, blah. It will not try to behave like it did on Windows, on Unix. On other systems, it may not be the case. For example, I have the luck of working on Solaris. And well, Solaris ABI is obviously by default defined by the ABI of Sun Studio compiler. If you use GCC, it's not the same one, period. And I think even Sun Studio changed it because at some point they gave up and used GCC internally, so they changed their own ABI. All right, I think that's a wrap. Thank you, everyone.